So what is percentile and what is decile? Percentiles are averages that divide the whole distribution into 100 equal parts. On the other hand, deciles divide the whole distribution into 10 equal parts. You can calculate any percentile by the formula Pi equal to Li plus Ni over 100 minus Fb all over Fi times C. Now, what does each of these stand for? Li is the lower class boundary of the ith percentile. For example, if I am asked to find this ninth percentile, my Li will be the lower class boundary of the ninth percentile. That is what it means, the lower class boundary of the ith percentile. N is the total frequency, Fb is the cumulative frequency before the ith percentile. So in the case of this ninth percentile, my Fb will be cumulative frequency before the ninth percentile. And C is the class size of the percentile. So if my percentile is 9, I will need to trace it back to the class boundary to know the class size, which is the difference between the upper class boundary and the lower class boundary. Now, similarly, the formula for calculating decile is di equal to Li plus n divided by 10, maybe Ni, because it could be the first decile, the second decile, the third, and all of that. Then divided by 10 minus Fb all over Fi times C, where di is the required decile, Li is the lower class boundary of the ith decile, N is the total frequency, Fb is the cumulative frequency before the ith decile, and Fb is the cumulative frequency before the ith decile, F is frequency of the ith decile, C is the class size of the decile. The students should also note the following are relevant. 100 percentile is equal to 10 percentile. Why? 100 percentile is the same thing as 10 percentile. Remember, 100 percentile is the whole of the data. It's like saying 100 divided by 100, which is 1. And 10 percentile is also the whole of the data, 10 divided by 10, which is 1. So 100 percentile is equal to 10th decile. The same thing, 50 percentile is equal to 5th decile. Because 50% is half of 100, 5 is half of 10, meaning 50th percentile is equal to 5 decile. 70 percentile is equal to 7 decile. Why? Because 70 divided by 10 is divided by 100, and that is 7 over 10. And also 7 divided by 10 is still 7 over 10. And so it goes like that. So the reason is that the denominator for decile is 10, while that of the percentile is 100. It is just a method of converting a mark out of 10 to a percentile and vice versa. We have an example here. Say the table shows the mark distribution of 50 students. This is the table. For the distribution, calculate the following: 15th percentile, 70th percentile, 9th decile, 6th decile, and 60th percentile. Remember that from this formula, what we have here is lower class boundary. Li is lower class boundary of the ith percentile, and Fb is cumulative frequency before the ith percentile. So the point I'm trying to make here, we don't have class boundary and we don't have cumulative frequency table, meaning we need to form that table first so that we can impute those values into the formula. What we have here is class interval. We need to get class boundary from that. So instead of using the class interval, I'm going to use class boundary. Max, my max now will be in class boundary. The class boundary for 16 to 20 is 15.5 to 20.5. If you have not taken the previous classes on group data, go and check it out. You understand class boundary. Or as a quick summary, the class boundary of a given class interval is anything that, of course, I can round this number to 16, then down to what? To to 20. So to form a class boundary from a class interval, just remove or reduce this first item by 0.5. Then add that 0.5 to the last one. That is the easiest way to get it. So like this now, instead of having 21, I'll have 20.5. And here become 25.5. Here will become 25.5. Here will become 30.5. So this one is decreasing by 0.5. Why this one increases by 0.5? I have 20.5 to 25.5. Next will be 25.5 to 30.5. The next will be 30.5 to 35.5 and 35.5 to 40.5, 40.5 to 45.5. Okay. Next thing is frequency. The frequency here is 2, here is 4, here is 15. Just copying the number direct into it. Frequency does not change. 9, 7, and 13. Next thing is cumulative frequency. Cumulative frequency. A cumulative frequency here still remains 2. 2 plus 0 is 2. There's nothing that comes before it. Then 4 plus 2 is 6. 15 plus 6 is 21. 9 plus 21 is 30. 7 plus 30 is 37. 13 plus 37 is 50. So n in this case is 50. This is n. Remember, we have n in our formula. Where is it? N. We have n in our formula. N there is 50. Now the question says we should find 15 percentile. So how do we get 15 percentile? 15 percentile in this case, P15, P15, which is Li plus Ni over 100 minus Fb over Fi n times C. The question is, how do we know what is L1 and how do we know what is Fb? 15 percentile is 15 over the total size of the data, which is 50. So 15 divided by 100, 15 percentile, 15% times 50, which is the total size of the data. 50 times 15 divided by 100 is 7.5. 7.5 or 7.5. So 7.5 item in our cumulative frequency will give us the percentile in question. So we'll go back to the table. We have 2, 6. So 7 should lie in this 21 here, since the cumulative frequency before 21 is 6, which is now up to 7. The 7th item is right here. So we'll trace it to the class boundary. L1 therefore is 25.5, the lower class boundary of the percentile. L1 is 25.5, and it's already 15, which we are looking for. Then FB, what is FB? The cumulative frequency. Let's go back there. You say FB is the cumulative frequency before the ith percentile. So in this case, before the 7.5 percentile. And now our 7.5 before the 15th percentile rather. The 15th percentile lie in the 7.5 item, which is right here. And what is the cumulative frequency before it? It is 6. So FB is 6. FB is equal to 6. Fi, on the other hand, is the frequency of the percentile in question. Our 15 percentile lies in the 7th position, 7.5 position. The frequency there is 15. So Fi is equal to 15. Fi is 15. YC is the class size of the percentile in question. The class size for the whole data is the same, 15.5 to 20.5. The difference there is 5. The same thing. So 25.5 to 30.5. The class size is, excuse me, is 5. So C is equal to 5. C equal to 5. Therefore, P15, the 15 percentile, will be, all this L1, 25.5 plus N is 15. I will 15 divided by 100 multiplied by 50 because we have Ni there, and minus Fb, which is 6, divided by 15. 15 times, let's reduce this fraction. 0 cancels 0. 15 times 5 is 75. And 75 divided by 10. Oh, I forgot to multiply by 5 here, this one. So I have 25.5 plus 75 divided by 10 is 7.5. So I have 7.5 minus 6 over 15 times 5. This will be 25.5 plus 7.5 minus 6 is 1.5. 1.5 over 15 times 5. 25.5 plus 0.5, which is 30. Therefore, the 15th, with 15, there's a here, 15 percentile. 15th percentile is equal to 30. Question 2 says the 70th percentile. And how do we get 70th percentile? 70th percentile is 70 over 100 n. Remember when we calculated 15th percentile, it was 15 over 100 n. So here now it will be 70 over 100 n. We want to calculate 35 percentile, for example, to be 35 over 100 and to calculate 8 percentile to be 8 over 100 and so on and so forth. So here we want to get the 70th percentile, which will be 70 over 100 times n. N is 50. 50 here 1, 50 here 2. 70 divided by 2 is 35. So the 35th item will be the item in that percentile. We go back to our cumulative frequency and locate that item. Here we have 30 here. 35th item should lie in this place because from 31 down to 37 is in this position here. So, and our required item is in 35th position. So it's definitely in this place. So we trace it. This gives us our L1 because L1 is lower class boundary of the ith percentile. So in this case, the lower class boundary of the 70th percentile is, what was the value? 35.5. L1 is 35.5. Then what else do we need? N is already known. Remember, Ni here will be N 70 over 100 times N. Then Fb is the cumulative frequency. Fb is cumulative frequency before the ith percentile. Our ith percentile in this case now is the item that lies in the 35th position. The cumulative frequency before it is 30. So Fb is 30. Fb is equal to 30. What else do we need? Fi now. Fi is the frequency of the ith percentile. Fi is what? frequency of the ith percentile. Our ith percentile is the 70th percentile, which lies in the 35th position. And what is the frequency there? It is 7. So Fi is 7. 7. Yc still remain constant. The class width doesn't change for a particular set of data sets. It's the same class boundary from beginning to end. So C remain 5. So we will put in all of this value, our 70th percentile, therefore P70 will be 35.5 plus, I'm putting the value into this, then 70 over 100 times n, which is 50, minus, this is ni here, minus fb, which is 30, and divided by 7, then multiplied by 5, 35.5 plus, remember this one give us 35 then, 35 minus 30 divided by 7 times 5, which is 35.5 plus 5, that is 35 minus 30 is 5, and 5 times 5 is 25, so let me just put it there, 25 over 7, 25 divided by 7 is 3.6, therefore our 70th percentile is 35.5 plus 3.6, and 3 plus is like 38, so everything 39, 39.1. 70th percentile, therefore, is equal to 39.1. Still continue. The third one says the ninth decile. For the ninth decile, remember decile is when we divide the data into 10 equal division. So how can we get the ninth decile? Let's clear this board. For the ninth decile, it will be 9 over 10 multiplied by the size of the data, which is 50. Ninth decile is 9 over 10 times n, which is 50. 9 times 5 is 45. So the item in the 45th position will give us the required whatever. And that will be in this final position here because I have 35, 37 here. 45 should be in this place. So my lower class boundary there is 40.5. Remember this idea is L1, Li rather, plus n over 10 minus Fb over Fi times C. So in this case, our L1, Li, how am I calling it L1? Li is 40.5. In Fb is the cumulative frequency before the ith decile. What is the cumulative frequency there? 37. Fb is 37. And then Fi is the frequency of the ith decile. Our ith decile lies in this place. The frequency there is 13. So Fi is 13. Fi is 13. With this, the class will still remain as C, which is 5. Still remain, that does not change for a given set of data. So if we put in all of this value, our ninth decile will be D9 equal to 40.5 plus 9 over 10 times 5, 50, minus FB, which is 37, then divided by 13 times 5. That will be 40.5 plus 45 minus 37 over 13 times 5. 45 minus 37, 8. And 8 times this 5 here is 40. 40 divided by 13 is 3.08. So we have 40.5 plus 3.08, which will be 43.58. So that's the ninth decile, therefore, is 43.58. Okay. The fourth question, we have to find the sixth decile. The sixth decile, let's get rid of all of this first. The sixth decile. Sixth decile, that is 6 over 10 multiplied by n, which is 50. 6 times 5 is 30. So our decile is in the 30th position. How do we get that? 30th position is right here. We have exactly 30 here. So that our Li is 30.5. That is, Li is lower class boundary of the ith decile. And our ith decile lies in 30th position. The lower class boundary there is 30.5. Li is 30.5. Then what do we need? We need FB, the frequency, cumulative frequency before the ith decile. Where is it? FB is cumulative frequency before the ith decile. Our ith decile is in the 30th position. The cumulative frequency before it is 21. So FB is equal to 21. What test do we need? We need Fi. Fi is the frequency of the ith decile. Our ith decile is in 30th position. The frequency there is 9. So Fi is 9. It's 9. Can now put all of this value into our formula. Di is Li plus n over 10 minus Fb over Fi times C. So D6, that is the sixth decile, is 30.5 plus Ni, that is 6 over 10 times 50, 6 over 10 times 50 minus Fb. Fb is 21, and Fi is 9. C still remain, I did not put it, C is constant for a given data. C is 5. If we put all of that into a calculator, we have 30.5 plus, remember we have 6 times 8, which is 30 there, minus 21 over 9 times 5. 30 minus 21 is 9. So we have 30.5 plus 9 over 9 times 5. 9 divided 9 is 1. 1 times 5 is 5. So 30.5 plus 5, which is 35.5. Therefore, the sixth decile is 35.5. And finally, the 60 percentile. This one is percentile this time around, no more decile. Let's prepare table or board rather than that. The 60 percentile will be 60 over 100 times n, which is 50. 50 here 1, 50 here 2. 60 divided by 2 is equal to 30. Remember we said earlier that 60 percentile is equivalent to sixth decile. So with that, we don't need to calculate further because I still have 30th here, meaning my 60th percentile should be the same thing as the sixth decile rather, which we have calculated earlier. 60th percentile and sixth decile are the same. So no need of calculation here. Therefore, our 60th percentile is also equal to 35.5. Okay, why? Let me still explain that 60 percentile is 60 over 100. 6 decile is 6 over 10. These cancel this, right? Which is 6 over 10. 6 over 10 is still the same thing as 6 over 10. So this is our answer there.